Hello, everyone. Welcome to Tracing the LLM Behavior, Debugging and Evolving Agent Workflows with Neo4j. Today we have Sridhan and Rangesh who are going to be presenting for us today, and also Ayushi will be supporting for Q&A. So Rangesh, I'm going to hand it over to you to take it away.
Thanks, Melody. So first off, thanks to Neo4j team for hosting this session and giving us the opportunity. To get started with, this session is going to be exciting and we'll focus on the most important aspect that our dev folks on day-to-day basis go through, tracing the LLM behavior. We all fire up so many queries to LLM agents, be it agents or LLMs, and then it goes to a black box and then it gives you a response. So we'll now try to capitalize Neo4j for it and could see how we could debug and evolve the workflows with Neo4j and how Neo4j could assist with tracing the LLM behavior. That is all the session is going to be. With that said, let me quickly jump on to the agenda. So first off, we'll set what the problem is, and then what is the solution that we propose, and then high level flow, perhaps talking about a very uh, high level architecture kind of stuff. And then we'll have the component trace and what we are trying to do, followed by a demo, and then Q&A. With that said, on to the next slide, Sri. Yeah. So meet the speakers, myself, Rangesh, and then I have my co-speaker, Sridhar as well with me, who will be taking through all of this LLM behavior session. On to the next slide, please. So yeah, so this particular laying out the foundation or laying out the stone, right? So if you look at the problem right now with all of the LLMs, we have different frameworks to develop things like be it Gamma Index or LangChain or N8 and name it, you name it, you have different frameworks to develop agentic stuffs. But be it in any of the frameworks, right? All the system does is you input with your prompts or you input with your tools, memories. You use all kind of all kind of supporting tools, right? So basically, you have tools in OpenAI. They call it as function callbacks, and in LangChain they call it a different terms, right? So basically, you augment different stuff to carry out your agentic stuff. So one important layer is tools. Number one is tools. Number two is memories. Number three is context. Number three is the handshake. Number four is the handshake that happens between agents or nodes or graphs, right? So so when you have all the sophisticated components in a complex agent, we always land into either of these four common problems. Number one, the tool misfiring. So when you ask a question, you have different set of tools. Now, how do you know that my agent has picked the right tool? That is always a black box for our developer folks. That is number one. Number two is memory blackout. So when I say memory blackout, you have limited context with LLM. You try to either gauge on the external memory or you gauge on the frameworks that provides the memory. Now you want to make sure that agent, the LLM or the agent or the nodes or the graphs definitely weigh on to these memories. Number three is you ask a question and then you never get a response from agent. It always loops infinitely, right? We never know why is it looping infinitely. There is absolutely no trace of it. Number four, the unexpected detours. So you lay down a path saying like, hey, I want to go from X to Z, but your LLM goes from X to C. You never know why did it take that route. So these are all the day-to-day challenges that our dev folks obviously undergoes. And you can say a point saying, hey, I do have a debugging tools like Langsmith and whatnot. But see, all of them are going to do postmortem activities. You go back and then see, hey, what has happened to it? But you never kind of, you know, draw a path saying like what has happened and why did the LLM choose that route? And that is what we are going to solve. So that's the uh, solution that we want to focus upon. In a nutshell, we don't want to fly blindly. We want to basically track and log and monitor how the LLM is behaving for every questions that we ask. That's all the session is going to be. Over to the next slide on the solution. So how do we do this? right? We have different graph databases, but why did we pick Neo4j? There's a reason that we chose Neo4j. My co-speaker Sridhar will emphasize on GDS and other aspects as we go through the session. So the intention is that for every function call or for every call, be it a tool or a memory or a conditional edges, for every edges or for every function calls that we make, we are going to track all of this using Neo4j nodes and graphs. So, and from there, once you have that, you could connect the dots, right? So once you have uh, two different nodes making two different stuffs, you connect to the different edges, and then say why it took this path. So that is the focus here. So basically, the whole solution is that you track and trace each and individual step of the no of the LLM, and then you track and trace with the edges, and then ask that question, why did it take it? And if it's the right path, you live with it, and if it's a wrong path, you basically track and trace and adjust and fine tune your LLM behavior. So that's the solution we propose. In a nutshell, the solution is that you're going to track each and every call that your framework may be it LangChain. This could be integrated with LangChain or Llama Index or any of that sort. So basically, we'll just track and trace and replay and you and replay with help of Neo4j graphs to know if it has taken the right path or not. So that's the solution. Uh, I'm handing it over to Sridhar. He'll deep dive into the level flow and demo on what.
Yeah, so thanks, Rangesh, and hey, everyone. So now that Rangesh has given a context to what we are going to solve with the Neo4j graph database, right? We will just dive into the layers that we have in our architecture. So the first and primary layer will be your agent system. So it could be any existing LLM agent framework, right? As Rangesh explained, it could be a LangChain or Llama Index or any custom framework that you might have built for your company or business, right? So that will be the primary agent. That will be the primary layer. So now the key requirement is we want to capture everything that an agent does. So it has to capture all the events, and in order to model it into a Neo4j graph. So in this case, what an agent does is it will transmit a set of events. So be it the thought process that it takes to arrive to a solution or throw out an error, right? Or and also the action that it takes. So from the thought process that it thinks about, and the action it takes, and also the result that it will finally give out, right? So all of these events will be important for us to model into the Neo4j, which will help us in debugging agent workflow. So the second layer will be our intermediate layer between the agent system itself and the graph DB, which is our observer or logger. So this is a lightweight middleware or library. It could be any connector that we could use, like Kafka, right? Its job is to listen for the agent events in real time and then transform them into Cypher queries. It transform them into nodes and relationships by using the Cypher queries that we are going to create for it. And one more thing is we don't have to hard code any queries. We can make use of other tools to auto code, right? So that is another aspect to it. But all that I wanted to tell is we have to ensure that every event is captured, and then it is persisted into Neo4j by the ciphers. And then now we will have all the traces of what an agent does from the first step to the second step to the third step, right? Every ongoing execution trace will be captured. And then the third layer that we have is the Neo4j graph DB itself. So this is our solution. So the problem that we are going to solve is to debug a workflow and to trace what path an agent took. This is our solution, and this will be the third layer. It stores the entire execution graph that an agent took, and this will help us in our historical analysis, post-mortem analysis, or be it for auditing or comparison with any other frameworks or models, right? Once we have this, we will then feed the information from the Neo4j graph DB to the to any of the dashboard frameworks that to any of the dashboards that we build, right? So in this case, like we have a simple dashboard which I'll be showcasing in the demo. So that will have all the insights we have from querying the Neo4j graph DB itself. So the information will be fed to this dashboard, and we can see for real time like how the agent's workflow is and the sequence, right? So this is the high level flow. And next, I would like to talk about the components or the traces, right? So this is just to explain on high level, like what kind of model or a graph model that we can have in terms of the nodes and relationships. So you could have a node like agent, right? You can have a node with a label called agent. This is the unique instance of a task. So whatever task that you want the agent to perform, let's say you want it to book a flight to New York City. So if that is the task that you wanted to perform, that can be mapped to a node called agent run. Then whatever steps that the agent will take can be modeled into this node called step. So each step will be a separate each step node will be a separate step that the agent takes. So in this case, a flight that needs to be booked to New York City, first the agent will think to get the user preferences, right? Once it gets the user preferences, it will then take the next appropriate actions. So this use case of booking a flight is just for an example. I'll be showcasing demo about another example, but yeah, this is the step node. And then we have the tool itself. So once it decides on a step, once the agent decides on a step, it needs to call the appropriate function, right? Those functions can be encoded in these nodes, which we can label as tools. So for example, get user preferences can be one tool, and then another function can be another tool. And then we could map a node called memory. So this is whatever context that the model gives out. For the model to achieve something, it will have a context for that particular use case, right? So for example, if it wants to store a log, right, like it can be stored in this memory node. And then we have the output node. So this is the final result, or like in case of successful completion, it will showcase the appropriate details, or if in case of error, it will just throw an error like invalid API key. So these are the node types that we could model, and the relationship types, right? So obviously, like this is self-explanatory. So step will generate a thought, then the step will decide to go to a particular tool, which the tool will take appropriate action, right? And then the step will use a memory node. And after a step is complete, it will proceed to the next step. So we could model it in this way. And then what output the step gives, whether it is good or bad. So these will be the relationship types that we have here. And then so this schema, it will help us ask whatever questions that we have for debugging a particular workflow. Like let's say you are asking a question and the agent is taking so much time, or it is giving you an inappropriate answer. We will be able to see, we will be able to pinpoint at what step what went wrong, or if a step went missing at all, or if a tool misfired, right? So these kinds of like complex questions can be like answerable by using the Neo4j graph model schema. So on the right, you just see a sample graph. Like I know that like this is just like too small to see, but this is not a big deal. Like I'll be going through a demo where I'll be showcasing how we actually like set up an agent by ourselves, just for a simple proof of concept. And I'll be showcasing how we can use Neo4j to debug something, right? So I'll be playing the demo. So Rangesh, let me know if you can see the demo getting played.
Yes, I can see it.
Okay.
And if you wanted to go on full screen, please do so.
Sure. Okay, just a moment. Okay, so the first thing that we would want to do is, so obviously, like when we want a particular task or goal to be achieved, we will be giving a prompt to an LLM agent, right? Like let's say we want to resolve a particular Jira ticket. Let's say its name is T42, and with the context from the knowledge base that we have within our systems and the templates that we have. So if this is the goal, then we are defining a main function which will run the triage for us. So it will contain all the necessary functions that it has to call. So I'll be playing through and I'll be showcasing how we have set it up. So this is the run demo.py file. So and then this file is the Docker compose, right? Like it contains the connection services that we have to Neo4j DB, right, and the other services that we want to configure. And then we have the Neo4j DB itself. So the third step is we have the Neo4j DB itself, which in which we'll be like modeling the steps that the agent takes. So then now we'll be we'll be going through the actual agent graph workflow itself. So this is the function that the main function calls, right? Like this run support triage will invoke a certain set of functions for it to actually model the graph that we want to build. So we are calling the build graph, which will create the nodes that we want. So basically, you see like 4 nodes here, like which are planner, retriever, toolsmith, summarizer. So I'll be talking in detail about that, like the expected workflow that we want to achieve. But these are like built once a successful completion happens. So here, let me just zoom into it. So here, if you see, like these are the steps that a successful workflow takes, because for any action, it has to first go to the retriever. The whatever prompt that we are giving, retriever has to take it. It has to provide it to the planner. The planner will then take appropriate action on what it needs to do. So what step it needs to take next. For which it has to call certain tools, which are provided by the toolsmith label that we have here. So in this case, we are having like 2 sample functions here. Like one is like fetch knowledge base and another is search. So the planner will call appropriate functions here. And then based on the output we got from the toolsmith, it will be provided to the summarizer here. So if you see here, the summarizer will take the output from toolsmith and it will summarize the output for us. And then the workflow ends. So this is how the ideal workflow should be. So now we'll be running this demo file, and I'll be showcasing how the UI looks once we run the demo. So we have performed the initial run, and then now it has started to build the graph in the backend. So as you see here, right, it has created all these nodes here. And then we will be starting the Streamlit service, which is the UI that we will be able to like visually see how the Neo4j traces have come out. So now running the Streamlit, it takes us to the UI. So over here, as you see, there are 3 steps, right? You don't see a step which is in between. So as you see, like you see retriever, you see planner, you see summarizer, but you don't see the important step in between, which the agent has to call. So the planner has to call the toolsmith, which got missed because of like the prompt that we gave or the hallucinations of the model. So ultimately, whatever prompt we give, that is going to give us the expected output, right? If the prompt is bad, the output will be bad. So in this case, something went wrong, and just to give a heads up, like we have intended to set it up in a way that it fails the first time and it will pass in the second time. So this is just to show how Neo4j can help us in debugging the workflow. So this is the expected output. And but then like we got this output, right? So only three stages got executed, and here we see the diagnostics, full diagnostics. We see only 3 phases, and this shows the find failure. So the summarizer step has failed because it did not get the appropriate information from the toolsmith. It does not know what to summarize. So again, it goes back to the planner and asks what to summarize, right? So that's what happens. So in this case, we have only 3 nodes. So next we will be running it again. Now in this run, it will run the workflow successfully. So by this, I can showcase you like how the actual workflow looks like. So here you see that you see all the 5 phases, right? You see retriever, you see planner, you see toolsmith, and then summarizer too. The planner in between, this is just to take appropriate action once it gets the desired output, right? The planner decides to summarize the output for us, and we see 5 nodes here. So here you can see there are 5 nodes, 4 edges, and we can also. So one more advantage with Neo4j is you can always model cycles. So basically, when there is a loop, one node will point like towards in the format of a cycle, right? So you can always like find out if there is an infinite loop. Like sometimes if you give a prompt to any of the famous LLMs that we have, right? It tends to like repeat the steps that it took and it fails to give us the appropriate response. So such kind of workflows can be debugged easily by using Neo4j by modeling it in this way. So this is the trace that we have, and so yeah, I'll then like second. Yeah. So this is just like a high-level model that on the POC that we have worked on to trace the behavior of an LLM. But this doesn't stop here, right? The thing is, Neo4j offers us so many algorithms which are available as part of GDS library. The reason why we chose Neo4j is it has several advantages over the other graph databases, particularly in terms of the inbuilt graph algorithms that we have. So in this case, we could answer a question like, let's say we want to find a path for a successful prompt. Let's say we want to find top 10 paths for a successful prompt. Like what a particular workflow that it took, right? We could use pathfinding algorithm. We could find the shortest path that an agent took to achieve a particular response, right? That is one use case. And another is we could also use centrality algorithms. Like let's say we want to let's say your agent threw an error or it is unable to come to the desired response. We could find out what kind of prompts or like how many prompts led to that particular error. So in that way we will get a score, and using that score we will be able to trace back to see like okay, there are 4 prompts, let us see what are the 4 prompts, and in that way we'll be able to rectify the prompt in the future. So we could avoid all such kinds of prompts and we could refine our prompts further. And another use case would be like community detection, right? Which will help us finding communities within our graph. So let's say we are working on a Jira task, and a Jira some task related to Jira API failed, right? So we could find all the prompts by clubbing those prompts together in a particular cluster. So all the nodes that has a particular cluster ID will be categorized together, and this will say, hey, these are the prompts that led to the failure of this particular prompt, right? This particular task. So these are the prompts that led to a failure of these particular tasks, and similarly you could club another set of use cases together. So this is another advantage that we could use with the help of Neo4j GDS. All right. So these are like upcoming things that we would be like expanding on our use case. So for now, like the simple POC is helpful enough to show us how Neo4j is powerful in helping us debug a workflow. So now with that, I would like to conclude by telling that we have so many advantages of using Neo4j to debug a workflow, right? One is explainability. So just doing a postmortem analysis on a bunch of logs might not tell us enough information, but using Neo4j, we can pinpoint to which step the error occurred, right? So that is one of the main advantages. And another is auditability. So we could maintain all the records, and it can also always be used for review in the future, or like for complaints, right? So for compliance controls, so that is another advantage. And obviously, like as we use graph, it is helping us in debugging the workflow faster. It goes from hours to minutes with the help of graph queries. So it just speeds up the process of debugging something. And then it also helps us in improving the processes continuously. We can always identify weak spots and then improve our agents prompts over time. And once that is done, yeah, sorry. Yeah. So, and yeah, I'm going to conclude. So the last step is like once we identify the um, weak spots, we can always call for action. We don't have to debug in the dark. We can start to use Neo4j to debug our LLM workflows. So with this, I'd like to conclude the session by saying that a graph DB always helps you in debugging a workflow, but the way Neo4j stands out is the variety of features and algorithms that it offers in-house, and the speed of the DB itself. So it is much faster than other DBs. So this is something that we have leveraged in our use cases, and we will continue to leverage it in the future too. So with that said, I'd like to thank everyone for presenting me with this opportunity, and I'd like to like take QA if anything is there. So thank you.
I think we got so many questions on the Q&A. I will try to respond as much as I could. So let me see if I could take any more questions. So Anil has asked, um, given your dependency is just an open telemetry data, assume we have no dependency on frameworks. Can we implement this to LangGraph, Crew AI? Yeah, it's definitely. So basically, this POC, right? What we did is like it's a bare metal, so it's you could always plug and play to any framework. So it's not tied only to LangChain, but in this POC we just use LangGraph. You could always go ahead with anything, be it AutoGen or 2A or anything of that sort. This is always bare metal. All right, I think we have a couple of minutes left. Any more questions? Please drop by in the comments. Yeah, thanks. Okay, yeah, I see a message from Jason to rate the session. Please do so. I think you guys should have definitely liked this. I saw more questions coming in, so I'm assuming the session went good.
Yeah, thank you, Harshit.
Okay, so Julio has asked, is it possible to apply Neo4j for data observability and analytics use case, avoiding other tools? Shida, you want to take this?
Yeah. So in terms of analytics, right? We could always have it to complement the other analytic tools that we have to trace our logs or anything, right? So we might have something in our system, but this use case that we have developed is particularly to show that Neo4j is capable to debug a particular agentic workflow, because agent is often like a black box model, right? Obviously, it will throw the logs and everything, but we want to model it in terms of nodes and everything and extract more insights out of it. So that's the main reason for using Neo4j to solve this use case. But to answer your question, yeah, like we could use this, but it's always better to complement it with the other tools.
Okay. So I think we are just left with minutes. There are no more questions. I think we can close it out, Melody.
Yeah, and for those who would like to connect with us, you can search for us on LinkedIn, and we would be happy to connect and like answer your questions. And maybe we can work on something together too.